Hello and good evening. Today we have with us Janine Benyus. Janine is a biologist, innovation consultant, and author of 6 books, including Biomimicry, Innovation Inspired by Nature. Janine co-founded the Biomimicry Guild in 1998 and founded the Biomimicry Institute in 2005. Janine, thank you very much for joining us today.
It's my pleasure to be here. Thank you.
Janine, my first question to you is, what is biomimicry and how is it related to sustainability?
The simplest answer is that biomimicry is innovation inspired by nature. It's the process of learning from and then emulating life's designs, life's processes, and life's ecosystem strategies in order to create a more sustainable world. The core idea is that life has been on Earth for 3.8 billion years. And in that time, life has learned to do pretty much everything that we want to do. It's learned what works, what technologies work here on Earth, what lasts, and most importantly, what's appropriate. So this is the process of looking at nature's technologies and strategies. They're very wise strategies because they were evolved in place, and applying them to human invention.
So, Janine, as you mentioned that the life of the Earth is 3.8 billion years, so is that the reason why you also call it Biomimicry 3.8?
Yes, exactly. And that name, it invites a question that allows us, sort of the obvious but not so obvious business case for biomimicry, and that is that in a world in which we need to reimagine everything, we need to redesign every system on this planet and every human system, and that there really is no longer running development program that we can look to than that 3.8 billion years. Only 1% of the species that have ever been on Earth are still with us today. So what we're looking at is quite a record of success. And so for us, it's looking to nature's patent database, if you will. How nature has solved problems through that long period of time. It just seems it seems quite obvious that this is a place for, if we want to create a more sustainable world, we should realize that we are embedded in one, that it's already been invented, and the invention started 8 billion years ago, and that there's much for us to learn.
Janine, for which business functions do you feel that biomimicry is most applicable?
That has been changing just about every year since I've been involved in this. There's a new application that comes. I started following the field in 1990 and wrote my book in 1997. And at that time it was pretty much, it was in the research lab. And there weren't that many commercial applications. But since 1997, what has happened is that industry has adopted biomimicry. It's jumped out of, it's still in academia. There are still a lot of research projects going on. But now industries of pretty much every sector of our economy are starting to bring biologists to the design table and try to see if there are some ideas that we might emulate. So the biggest fields right now are chemistry, material science, how we physically manufacture our world. There's an awful lot of incredible work going on. Of course, nature is nano. Nature self-assembles. The way nature does chemistry is completely different than we do in the industrial world. Nature does chemistry at low temperatures, inside its body, inside a body. So it's low pressures and life-friendly chemicals, and very, very low energy consumption. So those are all the things that we're now looking for in our manufacturing. So chemistry, I would say a very large body of work is done in computing. If you think about the fact that you use an antivirus program, you know, we learned from our own immune system how to fight viruses on the internet. There's all, if you look right now at bio-inspired computing, it's everything from what's called swarm technology, which is looking at ants and bees and other social insects to see how we might improve optimization programs within our computers. These are now becoming very, very common. Things like neural networks, where the computer is learning from your brain how to learn and become faster and more intuitive. That's a very, very big field. But there's also, in terms of who has adopted biomimicry, I think the product designers as a whole have really adopted it as an innovation method, and we work with a lot of product designers. Our company, we have an innovation consultancy, and we work in two verticals right now. One is product design. So we work at the front end of innovation with the designers. If somebody's trying to create a membrane to take salt out of water, we will help them by looking to the natural world and basically doing a survey of all the ways that nature recovers fresh water from salt water. So, you know, looking at all fish in the ocean and seabirds and mangroves, and then taking that thing to create, to look at design principles of that vast array of mechanisms. We look for some commonality, some design principles that an inventor who's making the membrane might be able to mimic. Right. So I would say that product design, and you can name any product in there, is now being looked at. Right. So we work with everyone from GE with medical devices. We work with Boeing on airplanes. We work with Nike on apparel. We work with large architectural firms on building-related products. Carpets, you name it. We've food science, furniture, pretty much anything in human endeavor. The other thing that's very, very popular, biomimicry has become very popular, is in the realm of the built world. So, and that's our second vertical. So we work a lot with, as I said, architects. We work with planners on cities, on applying biomimicry thinking to city redesign, which is very interesting. I think that are coming next, that we're going to get involved in next, is biomimicry applied to organizational design, leadership science, and management. Some of those design principles. Of course, transportation engineering has always been, biomimicry has always been very, very important there because of the drag reduction strategies that nature has. Right. Anything in clean tech, so solar, wind, wave harvesting, these are all things that are very, very ripe for biomimicry and are now being looked at. Other kinds of engineering, lightweighting, in the realm of lightweighting materials and building in new ways. I think the next very large area of endeavor that biomimicry is really going to be asked to be incorporated into is 3D printing, additive manufacturing. I think that the shapes and structures and interior architectures of biological materials will become the build files of our new our new material set as we're able to build layer by layer, and we're able to put whatever architecture we want inside of a structure. I think you're going to start to see, a lot of biomimetic.
Janine, for the benefit of our viewers, could you establish a correlation between biomimicry and business sustainability? So how would biomimicry relate to sustainability as a concept?
Well, when you think about it, we're not the first organisms on the planet to try to figure out how to live here with less energy, fewer materials. We are not the first organism to try to figure out how to create a circular economy. I mean, life has been using and reusing local raw materials and continually creating new products out of those raw materials for billions of years. So the whole all the concepts we talk about now, whether we're talking about energy efficiency, materials efficiency, circular economy, cradle to these concepts that we're talking about, even I would say on the management side, when you begin to look at ecosystems, and you look at how a system as a whole works, and you look at the new science that's coming out about how these systems, like a forest or a coral reef or a prairie, how do they knit themselves together? How do they continually enhance their places? And you begin to look at the nature of their relationships and realize that mutualisms, mutually beneficial relationships, really do drive success in these long-standing ecosystems. Even that concept, looking at what we now know we need to do to become truly sustainable, is to create an ecosystem of businesses that work together and that collaborate in the research lab, perhaps compete in the showroom, but collaborate in the research lab to solve some sustainability issues. Even that concept of cooperation and mutual benefit is something that you can find precedent for in the natural world. You can find, and not only precedent, but you can begin to look at what fosters cooperation in the natural world, and see if you could foster that in your business ecosystems. There's another term that's being talked about a lot, and that's resilience. And creating a company that can learn and adapt to quickly changing conditions, and that can, despite disturbance, retain its essential function. You know, its integrity of function. Those ideas of resilience come directly from the sciences, the natural sciences, in which we've looked at ecosystems that respond to disturbance and bounce back. And that whole field of resilience, we have been looking to those sciences for some clues to what makes a resilient company. Not just a resilient ecosystem, but a resilient company. So whether you're looking at new products that are more sustainable, new manufacturing processes that are more sustainable, or if you're looking at new frameworks for sustainability, I think all of those are now finding some guidance from the natural world.
Janine, from your experience, how do you inspire managers or motivate managers or leaders who may not have a strong background necessarily in biology to take up biomimicry for sustainable innovations? Janine, from your experience, how do you motivate managers and business leaders who may not necessarily have a strong background in biology to take up biomimicry for sustainable innovations?
You know, biomimicry is really a team endeavor. We have a company of biologists that we bring to the design table, but the work of actually innovating with natural models is done by the the engineer and the biologist, the business person or the manager and the biologist, the chemist and the biologist, right? So actually we teach an 8-month course for certified biomimicry professionals, and these are people who want to bring biomimicry in. They're practicing engineers, and they want to bring in biomimicry. I can wait here for this. Do you hear that? Do you hear the? So we teach certified biomimicry professional courses, and all from an 8-month course all the way up to a 2-year master's course. And in each of those courses, we have a cohort that involves not just biologists, but biologists, business people, engineers, and designers of all stripes. And that's because our belief is that you may not, but once the biology is translated to you, you can certainly take that and take those design principles. You don't have to be a biologist to understand those design principles, or to say to yourself, you know, I think that most people who are in sustainable innovation are eager to look anywhere they possibly can for new ideas that work. And so I think even though you're not a biologist, most of our clients actually, and they're Fortune 500 companies very often, or governments or communities, but you know, very, very large companies come to us office because they're looking for a breakthrough idea, a new way of doing something. The sustainability comes with the process because these organisms are inherently sustainable, or else they wouldn't be still on this planet. But the novelty is actually what I think, there's novelty and sustainability, but people really get excited about. There's a study that was done by a man named Julian Vincent in the UK. And what he did was, he was trying to figure out just how novel are these natural technologies, these natural ideas. And what he did was, he looked at an analysis of the human patent database. And this is something that's in a innovation methodology called TRIZ, T-R-I-Z. So that had already been done. And somebody who had gone through all of the human patent database had said, okay, every time humans are faced with a particular problem, we want it to be lightweight, but we want it to be strong. What are the inventive principles that we always use over and over again? You know, we might make it porous, or we might give it a structure like an I-beam. You know, these are the inventive principles. He then went and he took the same set of problems and he looked into the biological literature and said, how has the rest of the natural world solved this? And he expected to find a huge overlap, that we had stumbled upon things that nature had already stumbled upon, right? Actually, that's not true. He only found a 12% overlap in the way that we solved problems and the way the rest of the world did, the rest of the natural world. What that means is that 88% of the time, if you're looking into the biological world for your idea, you will be surprised. There will be a new idea. So I think that's one of the strongest things that you can say, especially when we go into businesses. We say, don't do this because you want to have one product line that's green. Do this because this is an innovation that can be a platform across your entire product line. You know, let me give you an example. How nature creates color. So nature creates color, we create color with paints, with pigments. A lot of paint companies that have come to us, and they use a lot of heavy metals. And in dyes, in textile dyes, there's a lot of heavy metals to get that coloring. In the natural world, the most brilliant coloration is not done with pigments or dyes. It's done with structure. It's called structural color. So if you take a peacock, that peacock has the only pigment in it is brown. It basically creates those colors by having many, many layers, transparent layers of keratin, which is like your skin or your hair. And those transparent layers play with light in such a way to create the color blue to your eye. Change the structure a bit, change the layers, the thickness of the layers, and you get the color green or the color yellow. There's no need for dyes. So that is a completely new way to do color. So when someone comes to us and says, we want to figure out how to do a formula for the color yellow without cadmium,
right,
we say, maybe you should look into painting or creating a thin film of transparent layers. Or maybe you should create a thin film wallpaper that can be changed with a dial, that you can move the layers in and out and create any color you want. Maybe, as Sherwin-Williams, you're not so much in the paint industry as you are in the color creation industry. And maybe you should look at new ways of doing material science. This is what people are looking for.
Right. Janine, where can businesses learn and find about ready-to-adopt technologies based on biomimicry?
Well, I think one of the best places to look for case studies on biomimicry is a website that we created called asknature.org. And what this is we built it to be a source of inspiration for inventors. It's biological strategies organized by function, by design and engineering function. So you can type in, how would nature create color? Or how would nature reduce drag in fluids? And up will come strategies. And then if somebody has mimicked one of the strategies, say one of the strategies is the humpback whale, and how the humpback whale has a flipper that on the leading edge of the flipper there are scalloped edges, and those scalloped edges play with water flow in such a way as to drastically reduce drag. And that has been mimicked in a wind turbine blade. There's a company called Whale Power in Canada that's making fans and wind turbine blades and using that same scalloped edge on the leading edge of all kinds of blades. And you'll find that case study by typing in drag reduction, and up will come humpback whale, and then up will come that case study. We have I think there's about 160 products and companies right now on the site. And that's just a really good way to keep up to date with the field, I think.
Great. Janine, what are some of the important trends that you foresee in biomimicry going ahead?
I'm watching a couple of things right now. One is agriculture, actually. And interestingly, we're getting approached now by very, very large agricultural firms, dairy, milk, ranching, all kinds of crops, commodity crops, palm oil. People are beginning to realize, how do we do these things sustainably? How do we grow potatoes, which is now suffering again from late blight, what caused the potato famine? How do we grow potatoes without using huge amounts of pesticides, fungicides? How do we do ranching or dairying in a way that doesn't create huge amounts of methane, which cattle create? And that's a climate change issue. It's very, very interesting. How do we farm in ways that sequester more carbon? Very interesting. So I think what I'm seeing there is that the era of genetically modified plants as a technology to help us feed the world has not is not biomimetic, but it certainly hasn't yielded what we thought it was going to yield. And it's time to take another look at the farm as an ecosystem and realize that it's not just the plant we're trying to protect or improve productivity. It's not just the plant. It's actually a whole ecosystem. If you look at the soil, what we're realizing is that the idea for biomimicry might be to mimic healthy soil ecology, because in that soil there's lots of fungi and bacteria that are helping that plant get its nutrients, get its water, learn about pests before they're there. There's a common mycorrhizal network, a fungal network that connects plants to one another. And that's basically lost from our croplands right now.
Right.
Because we give the plants fertilizer, and then those fungal helpers and bacterial helpers, we basically say that they're not needed. So I think what's going to be happening with agriculture is to try to help the helpers, which is a big shift from genetically engineering a plant. So I think that's going to be a big, and everything from, and not just cropland. I think it's going to be an aquaculture as well, as we try to feed a growing population in ways that do not that enhance the place rather than degrade it. I think another big area, as I mentioned before, a second area that I think is very ripe for biomimicry is additive manufacturing. Additive manufacturing, this ability to build products layer by layer according to a very specific blueprint, is an enabling technology. Secret of what nature does is, and how nature is able to recycle everything, is that life basically uses a very, very small material palette. And this material palette, for instance, long chain molecules, and there's really only a couple of types, polysaccharides and proteins, and then of the materials that are used, there's about 5 of them that are used over and over again. So things like keratin, like your hair and your skin, collagen, chitin, which is insects, exoskeletons. There's only a few of these kind of classes of materials. But what life does is it adds exquisite design to these materials. So when it, for instance, a beetle's exoskeleton needs to be strong, it takes that chitin composite that is one of the most common materials in the world. Also comes from seafood waste. We've got a lot of chitin that we burn currently. We could be using in a circular economy kind of way. But what a beetle does is it takes that chitin, and when it wants to be strong, it lays it up in a plywood hatch. Or when it wants to be breathable, it builds a pore in the chitin, or it puts layers down to create color to your eye. And that is something that, say we used, if 3D printing is to be using local raw materials, we should be adding exquisite design to those raw materials in a chemistry that's very safe. So that's biomimetic chemistry. And then we should be taking that material at the end of its life. Say you go and you get a shoe printed out for you at a shoe store. You should be able to take that back and have that shoe made of one material with many different functions in that material, sponginess or softness, whatever, that one local raw material, that then you take that shoe and bring that back to the printer and then you've got a circular economy. You actually break that shoe down in an enzyme bath or whatever and unzip it, if you will, and that's the material for your printer. That combination of safe chemistry, perhaps, this is not the way it is now. We really have to get ahead of this. Biomimicry has to, I think, start to inform 3D printing. But you can imagine if we were able to take biological chemistry, add biological structure, and then add the strategy, the business strategy of returning the product. Suddenly you have the next industrial revolution, and it looks more like how the natural world works. So that I'm really paying attention to, doing a lot of. I just did a TED talk on it. So I'm really and I just did a New York Times op-ed on this. It'll be published soon. So there's that's something I'm really looking at. That and agriculture. And then the third thing is biomimicry applied to cities. I think, obviously the world is 70% of the world is going to be urbanized by 2050. They're predicting, and places like India and China are going to have dozens of new large cities. So the idea is how do we make a city function more like a healthy forest, right? And so what we do there, and I just got back from a conference in which a work session with the global mapping company called Esri. And what we're trying to do there is say that we know, and actually I worked on a project in India doing this. We know that wildlands produce a certain number of ecosystem services. They clean water, they clean air, they clean soil, they store water, they protect against floods. We're asking the city to have the same level of ecosystem service production, to produce the same amount of ecosystem service as the wildland next door. We call it ecological performance standards. And that's a very interesting framework. I mean, and from your audience of business people would relate to this. If you know about environmental profit and loss statements that people like the CEO of Puma have been working on, and Richard Branson's B team, which is a group of executives of CEOs that are taking on sustainable frameworks. The framework they've decided to take on is environmental profit and loss. So they're adding up how many ecosystem services it takes to produce their product. So, how much does it take to produce a Puma shoe? But that's on the loss statement. What's on the profit statement? What is Puma, with all of its facilities all around the world, how much clean water does it create? How much clean air does it create? Do its facilities actually take in air and clean it? Do they clean water? I mean, this is very interesting. So I'm watching now people. The new business trend is to add up the losses. When we start adding up the profit, and perhaps we get to the point where there's a market for ecosystem services, you might actually get paid for cleaner water. That becomes very interesting, right? And so, but that will beg the question: how do we clean air, clean water? How do we do that? And again, that's a right place to look to the rest of the natural world that's been doing this all along. Not just to look at the wildland next door for the metrics, but also for the models of how to do it in your part of the world.
Janine, thank you very much for sharing your views with us. Thanks a lot. We really appreciate you.
You're welcome.
We really appreciate you joining us, and look forward to talking to you again. Thank you so much.
You're welcome. Thank you. Good luck.